Hello students, welcome to the lecture number 5 on aldehyde, ketone and carboxylicacid chapter. In this lecture we are going to discuss another very important chemical reactions as being undergo by the aldehyde and ketone. In the previous two lectures, that is the lecture number 3 and lecture number 4, we have also discussed about some very important chemical reaction as undergo by the aldehyde and ketone, that is by this aldehyde and ketone. In the fourth lecture we have discussed about the oxidation and reduction reactions as being carried out by the aldehyde and ketones. And in this lecture we are going to discuss another very important and we will say this will be the remaining of all the chemical reaction that we must know, and that is very important chemical reactions. So heading of today's reaction, today's lecture is the aldol condensation, and along with we will discuss the electrophilic substitution reactions that is undergo by the aromatic aldehyde and ketones. So heading of today's lecture is so in this lecture we are going to discuss two different very important chemical reactions, that is the aldol condensation and the electrophilic substitution reaction that is being carried out by the aromatic aldehyde and ketones. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So first let us understand the aldol condensation. Aldol condensation reaction is basically, it is comprised of the two reactions. First, that is the formation of the aldol, and second, by elimination of the H2O, it will become condensed and it will give another product, that is unsaturated alpha beta unsaturated aldehyde or ketones, that is the aldol condensation product. First, let us understand why the ketones or aldehyde going to undergo this type of aldol condensation, and what are the primary requisites that a aldehyde or ketone can able to undergo this reaction. That is basically there will be at least one alpha hydrogen atom. That is the main thing that we have to understand. Alpha hydrogen atom. Alpha hydrogen atom, presence of the alpha hydrogen atom in the aldehyde and ketones, that will going to carry out this aldol condensation. And it is basically the very high acid property of the alpha hydrogen atom, and that is due to this reason, that in two reasons behind which the alpha hydrogen of the aldehyde and ketone is very much acidic. That is number one, that is the strong electron withdrawing effect. Strong electron withdrawing effect of electron withdrawing effect. Strong electron withdrawing effect of the carbonyl group. First and second is stability of the conjugate base. Stability of conjugate base by resonance. The two important factors that are going to affect the alpha hydrogen of the ketone or aldehyde is acidic, purely acidic. How it is? Let us understand. This is, first let us understand what is alpha hydrogen atom. This is the carbonyl group, and in this carbonyl group there is one hydrogen atom is attached to it, and here you will find there is a hydrogen atom, and this hydrogen atom is the alpha hydrogen. This is alpha hydrogen. Okay, and when by a base this hydrogen atom has been coming out from this aldehyde or ketone, it is going to produce the base, that is conjugate base. So, and this is due to this fact, this is high strong electron withdrawing effect of this carbonyl group, and this hydrogen atom which is bonded to this alpha carbon, this is the alpha carbon, and so that it is alpha hydrogen, it will be coming out from this aldehyde or ketone, and it will become the conjugate base. So conjugate base is this, and this conjugate base with this is the conjugate base, and this electron which is remain in the carbon atom is being delocalized by a very interesting phenomena that is called the resonance. So with this, what will going to happen? This electron will go shift to this position, to this carbon-carbon single bond, and this electron, pi electron will go to there, and it will create this. The charge will, you can see, delocalized from here. The negative charge is delocalized from here to here. So there is a resonance between these two conjugate base. This is basically a conjugate base, and due to this resonance, this minus charge which is generated due to this fact there is the hydrogen atom has been coming out from this aldehyde ketone, and this charge, negative charge, is delocalized, and that is why it is very stabilized. Stability has been arrived, stability has been done, stability is observed in the conjugate base, in this conjugate base, and so it is going to be formed. So there is two things basically which leads the alpha hydrogen is highly acidic, that is the strong electron withdrawing effect of the carbonyl group, and number two, stability of the conjugate base by resonance. I think this is clear. Now we will discuss the reactions of the aldol condensation. So what is aldol condensation? When the ketone or aldehyde which is having at least one alpha hydrogen atom in presence of the dilute NaOH, dilute alkali, it is going to one molecule will combine with the other molecule, and it will going to form the hydroxy compound, hydroxy aldehyde or hydroxy ketone, and this is called the aldol product. And subsequently, in presence of H plus, that is the acid, it is further being reacted and further being transformed into the another product by elimination of H2. It is called the aldol condensation, which is the alpha beta unsaturated aldehyde. So aldol condensation, basically first there is a preparation, formation of the aldol, and after that with the elimination of the H2O in presence of acid and heat. When you heat it, it will become a alpha beta unsaturated aldehyde. Okay, so we understand this reaction. There is basically two molecules will simultaneously react with each other. This is one molecule of, this is acetaldehyde. This is acetaldehyde, and here another molecule of acetaldehyde, where this is the alpha hydrogen. Reaction will go when this hydrogen, due to its high acidic power, acidity, it will be coming from this, and there is a negative charge. It become a nucleophile. When it is a nucleophile, and we know here this electron will goes there and it will move here. When it will move here, the electron will goes there because to satisfy the carbon 4th valency. Because if this double bond is there, single bond is there, single bond, and another bond is formed, then carbon will have the 5 valency there, but that is not possible. And due to this, these pi electrons will shifted there. It is a negatively charged, and it will take up some hydrogen ion, H plus ion, from the reaction path, and it is going to prepare this product. And this product name is aldol. This is aldol because here you can see one aldehyde group is there and another is OH group, means alcohol group, alcohol, which is making the compound a alcohol. So ALD comes from the aldehyde and OL comes from the alcohol. That is why it is called aldol, aldol condensation. So the name of this compound we can say that is beta hydroxy, because hydroxyl group at the beta position, beta hydroxyl butyraldehyde. This is beta hydroxy butyraldehyde, or IPSC name we can say 1, 2, 3, 4. So we can write 3 hydroxy butanal. Okay, so this is the aldol reaction. This reaction is called aldol reaction, and further in presence of H plus ion, in presence of dilute acid, and when we heat it, give some heat to this product, there will be the elimination of one molecule of H2O, and this one molecule H2O by this with this OH ion, and here this one hydrogen atom will combine with each other, and it will comes out from this aldol product, and it is going to give the aldol condensation product. This is called the aldol condensation product, and it is also called the alpha beta unsaturated aldehyde, and IUPAC name of this compound is 1, 2, 3, 4. So you will say this is butane, but 2 in L, because in the second position there is a double bond 2 in L, but 2 in L. So this is the aldol condensation product, and it is alpha beta unsaturated aldehyde. Okay, In the similar way, ketone also going to undergo this. Ketone also going to undergo this in presence of dilute NaOH. So this will add to there and we will get OH, CH3, CH2, and you can see here in this product it is one keto group and another functional group, the OH group. That is why it is called ketone. Ketone, as like aldol. And when there is a heating, we are heating it, and with presence of H plus ion, it will acid, it will plus, and this, and name of this compound is, we can write, that is 1, 2, 3, 4, 5. It is 4-hydroxy, 4-methyl, 4-hydroxy, 4-methyl pentan 2, 1. This is IUPAC name. 4-hydroxy, 4-methyl pentan 2, 1. And when this product, that is the aldol product, basically you can call it as ketone, and when it is being eliminated, there is being elimination of one H2O from this one hydrogen from here and from this OH, it will going to produce alpha beta unsaturated aldehyde ketone. Here it is a ketone, alpha beta unsaturated ketone, and name of this 1, 2, 3, 4, 5. So we write this is 4-methyl, pent, and here you can see there is a, in the 3 number position, there is, because this OH has been from this OH and this position, to paint, that is 3N2,1. That is the name of this aldol condensation product. But this is also, you can say, ketone. This ketone group is associated with it, but we will commonly call it is a aldol condensation, irrespective, because of this fact in both the cases, for the aldehyde and the ketone, they are having the aldehyde carbonyl group. So 4-methyl pent 3N2,1 is produced. Aldol condensation, when there is another type of aldol condensation, this is called the cross aldol condensation. Cross aldol condensation. Cross aldol condensation, when this aldol condensation is going on between the different aldehyde or different ketone, or ketone and aldehyde, it is going to this aldol condensation is called the cross aldol condensation. Suppose this aldol condensation is going on between this aldehyde CH3CHO plus CH3CH2CHO, that is acetaldehyde or propanaldehyde, or you can say ethanol or propanol, ethanol and propanol. This is ethanol and this is propanol. When this is being carried out in presence of the, and there is, you can see there is a alpha hydrogen here in the, here is 3 alpha hydrogen present, here it is 2 alpha hydrogen present. So both the compounds having this alpha hydrogen, at that time you can see that it is the product, 4 products will be produced. 4 product has been produced. And what are the 4 product? Because when CH3CHO plus CHO, this will give a one product, and that is already we have discussed, that is CH3 CHO. This is but2NL. Similar fashion, the propanol CH3CH2CHO plus CH3CH2CHO, and this will again give a product, right? Now when CH3CHO plus this, that is ethanol and plus propanol, CH3CH2CHO, this will give a product. Now in this case, the alpha hydrogen of this propanol has been used and one aldol condensation product is produced. And another 4th number cases, in this case CH3CH2CHO plus CH3CHO. Here the alpha hydrogen of this acetaldehyde has been used and it is going to produce different type of product. That you can easily able to make the reaction. Very simple. You have to take this alpha hydrogen, it will become a side chain and it will join in this fashion, and there is a elimination of the H2O. Similarly, here also you can do yourself, here also you can do yourself. So this is the cross aldol condensation. Another type, this is between the aldehyde. Now between the aldehyde and ketone. Suppose now cross aldol condensation between the aldehyde and ketone. That is, as for example, this is benzaldehyde. This is benzaldehyde and we are taking the acetophenone. This is the acetophenone and this is benzaldehyde. And here also you can see, here it is the alpha hydrogen, but benzaldehyde do not have any alpha hydrogen. But in this case, what will, in presence of dilute NaOH, the product will be this. Here you can see this alpha hydrogen, you can write this here like this, and this will be joined to this, and here and this will go, this electron, pi electron will go to oxygen atom and it will going to produce this. This is the aldol product. Now when you heat it, it is going to produce this one hydrogen, and this OH has been eliminated as a water molecule, and it is going to produce this. This product is going to form, and name of this 1, 2, 3. This is 1,3-diphenyl. 1,3-diphenyl prop 2 in 1, 1. So you can see 1,3-diphenyl prop 2 in 1, 1. That is for the keto group. Because there is a 3 carbon atom, so it is a propane, and it is propane 2 in the 2 number position. There is a double bond, and 1 number position there is a keto group 1, 1. Okay, so this is the cross and aldol condensation between the ketone and aldehyde. This is the aldehyde, benzaldehyde. This is benzaldehyde, and this is acetophenol. Okay. Now there are some aldehyde. This is for only aldehyde also. Some aldehyde like formaldehyde, like benzaldehyde, they do not have any alpha hydrogen atom. So in this case, in the concentrated alkali, it is going to produce a reaction which is called the Cannizzaro reaction. In this case, there is a disproportionation reaction which occurred, means one molecule will oxidize and other molecule will be reduced to the alcohol. One molecule will oxidize to the salt of this corresponding acid, and another will be to the alcohol. So let us understand this. There is Cannizzaro reaction. This is basically called the disproportionation reaction. Disproportionation reaction. Disproportionation reaction means it is basically one molecule, two molecule will take part as same way, and the aldol condensation we have seen that one molecule will react with the other molecule, and one molecule alpha hydrogen will be liberated from there, and it will be a nucleophile and it will add to the other carbon atom. So it will going to produce aldol, and this aldol is ultimately being further processed, that is by elimination of the one molecule of hydrogen, and there is a unsaturated aldehyde you can observe. In the same fashion, two molecules will going to take two molecules of this formaldehyde, because here there is no alpha hydrogen. In presence of the concentrated NaOH, suppose 50% NaOH is given, and it is going to produce methyl alcohol, and it is going to produce sodium salt of formic acid, sodium formate. So it is going to produce. So this is methyl alcohol or methanol, and it is a sodium formate. Sodium formate. So here you can see one molecule has been reduced and another molecule is oxidized. This is called disproportionation reaction. Self-oxidation and reduction reaction, and this is called the Cannizzaro reaction. In the same fashion, in case of aromatic aldehyde also we can observe this 6,6H5CHO. This is benzaldehyde. Benzaldehyde, and in presence of 50% NOH, it is going to produce the benzyl alcohol. This is benzyl alcohol. And sodium benzoate. And this is sodium benzoate in the similar fashion that we have discussed in case of formaldehyde also. This is called the Cannizzaro reaction. The mechanism of the Cannizzaro reaction is, it is basically a hydride shift. With this, that is going to produce these two products. Okay. Because another more important reaction, that is the electrophilic substitution reaction. Electrophilic substitution reaction. This reaction is undergo by the aromatic aldehyde or ketones, and we know the carbonyl group is highly strongly electron withdrawing groups, so it is going to deactivate the benzene ring. So the reaction, in this reaction, when it is carried out, in this case it is, this will deactivate this benzene ring, and that is why it is meta-directing. So when nitration reaction is going on, H2SO4 and HNO3 in a temperature 273 Kelvin to 278 Kelvin, it is going to produce, as the group is meta-directing, it is going to produce this product, that is meta-nitro benzaldehyde. Nitrobenzaldehyde, nitro, and this will be in the continuous benzaldehyde. There will be no gap. Meta, there is slash, then nitrobenzaldehyde. Okay, this is benzaldehyde. Okay, so that is all for today's lecture. In this lecture number 5, we have discussed about the very important chemical reaction, that is the aldol condensation and the cross aldol condensation. Also, we have discussed the Cannizzaro reactions, and also we have discussed the electrophilic substitution reactions of the aromatic aldehyde and ketones. Hope all the points is clear to you. It is basically a service to the students who cannot able to afford costly tuitions nowadays, which is getting costlier and costlier. I think this is going to help them in understanding the concept and achieving their targets, achieving whatever in the board exam or in the competitive IIT, JEE, NEET, whatever, it is going to help them. Thank you very much for watching.